this second video, I'll introduce you to a few key operations used for assemblies, how to fasten parts together, how to create sub-assemblies to more efficiently CAD your robot, as well as the best places to mount your brain, battery, and radio. Now, the most important mate constraint you'll use is the fasten mate. This mate allows you to connect parts together and lock all translational and rotational movement between them, so they essentially act as one part. The next mate is the revolute mate. When it comes to assemblies, you won't really need to use this unless you're trying to model rotational motion. This mate allows you to mate two parts together such that one item rotates about the other. For example, you might use a revolute mate to model rotation of a wheel about a screw joint. A couple other useful tools that are pretty self-explanatory are this replace instance tool, the linear pattern tool, and the circular pattern tool. So I'm going to demonstrate to you how to use a fasten mate by simulating a connection between two VEX metals. So as you can see here, I have two C-channels, a screw, and a nylon nut. First thing we're going to do is, of course, just open up the fasten mate connector. You can hover over whichever hole you want to use for this connection, and I'll be using this one. As you can see, a whole bunch of these little dots show up. These are called mate connectors, and these are all the possible places where connections can be made. Typically when you use VEX metal, you want to select the dot in the center of the hole that you're using. It's kind of hard to access the centered dot, so I use my screenshot tool. On Mac, it's Command-Shift-4, which freezes the screen, and then I'm just able to go ahead and hover over that dot and select it. So as you can see, you've now selected the first mate connector in your fasten mate. Now I'll go ahead and connect it to this hole here and repeat the same process. And as you can see here, they're now fastened together. You can use this tool to flip and this tool to rotate. So I'll leave it as this. Next thing we want to do is insert the screw into this hole and then insert this nylon nut on the other side here. For screws, you want to use this bottom face here and then just fasten it to that same hole. And again, with your nylon nut, you're going to use this bottom face here, fasten it like so. There we go. When you're CADing your robot, it can be a bit painstaking to keep recreating the same assemblies over and over again. For example, in a 450 RPM drivetrain, you have 8 wheels. That means you have to CAD 8 wheels as well as all the individual parts that are connected to it. That can take a lot of time. Something that will turn out to be very handy for you is using sub-assemblies or smaller assemblies in a separate tab that can then be reused and inserted in the main assembly. So here I've created a wheel subassembly for a 450 RPM drivetrain. This is a 2.75-inch Omni wheel, and this is a 48-tooth gear. I'd like to give a short side note before I show you how to use these subassemblies. As you can see here, there's a gap between this bottom face of this 2.5-inch screw and this caps nut. However, they're still fastened together using a fasten mate. This is called offsetting. You can see here that I've offset the screw from the nut by 0.062 inches in the negative Z direction. The offset allows you to lock all degrees of freedom together whilst also allowing separation between the parts. Now, once you go back to your main assembly, building your drivetrain is super straightforward. All you need to do is head over to Insert, go to your current document and Assemblies, and then insert your wheel assembly. From here, all you need to do is fasten your wheel assembly to your drivetrain frame. What I'm going to do is I'm going to fasten the bottom face of the screw head to this hole right here, since in a 450 RPM drivetrain, the wheels are offset from the motors. Now that you know how to do that, you're ready to go ahead and start inserting the rest of your wheel assemblies. Once you're finished with all your wheels, this is what one side of your drivetrain should look like. Now I'll give you the challenge of creating your own motor subassembly and using that to finish off your drivetrain. For this last part, I'll be showing you where to put your brain, battery, and radio. As you can see here, I have an example, but let me just go through why I put them where I did. The most important thing when it comes to these three is accessibility and safety. The officials must be able to turn your brain off at any time, so keep that in mind. But you also don't want other robots to be ramming into any of your key electronics. Also, keep your battery cable length in mind. It's always better to position the battery as close to the brain as possible so that your battery cable has a lower chance of being dislodged from the brain. Lastly, for the radio, since all we currently have is a drivetrain, you have a bit more freedom for where to position it. The same rules as before apply. Keep the radio safe and in a position where the wire can reach the brain without risk of disconnection. However, once you start adding more assemblies to your drivetrain, the positioning of your radio becomes a bit more complicated. According to the VEX library, here are some of the best practices when it comes to your radio. The higher the mount location on the build, the better. Do not mount the V5 robot radio in a steel box, meaning do not surround it with metal. Keep the thinner part of the V5 robot radio away from the other metal. If you don't follow these suggestions, you run the risk of the radio disconnecting. So now back to the example. As you can see, I've placed all the electronics where they're accessible but also safe so that other robots won't be able to ram into them. The battery and the radio are right next to the brain so that the wires won't be easily dislodged. Of course, this is not the only configuration. You can work out a configuration that works for your robot the best. As one last side note, I'd recommend that you make sure to use these clips that I've highlighted here on either side of the brain, as well as clips for the battery. It is especially important for the brain because if you are to screw the brain directly into metal using the holes on the back, you run the risk of shortening your brain's lifespan, as the direct connection between the brain and the metal can lead to static electricity, which can fry your brain. So again, make sure to use these clips to improve your brain's lifespan. And we're done now. So hopefully this video was useful for you and you are now ready to CAD your own robot.